Then we come to our next session, and it's about Kubernetes and how we can use it through OpenShift. And for that, we have an amazing speaker, and we were very glad he could be here because we had some technical setbacks, I think, a couple of hours ago, but he's here. I think he's here. It's Nigel Brown, developer advocate at the IBM Cloud. Nigel, are you here?
Hey, I'm here. Can you hear me?
We can hear you, certainly. So
Awesome.
good you could be here.
Yeah, I'm glad to be here. I'm very happy to be here.
Because normally you're probably in Texas, you're in Austin, Texas?
Yeah, that's correct. I'm in Austin, Texas.
But currently you're not in Austin, Texas?
No, I am. I'm here.
Oh, you are? Okay, well, excellent. Then, yeah, I only know aka.ms in Azure for a Kubernetes solution. And I'm really looking forward to how we can do this through OpenShift. And I think you're going to tell us how we can do that.
Of course, of course. Are you able to see my slides?
Oh, could you please share the video? I think we could see your slides. I'm now looking to check. Yes, you
Yeah.
can certainly see your slides. And could you share video as well?
The video is on my end. I can turn it off and back on again.
Oh,
Yeah,
there
that
we
always
are.
works.
There it went.
Perfect.
Okay.
We can see you as well.
Okay.
Thank you so much. Well, the floor is yours.
All right. Thank you so much. Hey, y'all. I'm very excited to be here with y'all. My name is Nigel. I'm a developer advocate at IBM, and I want to talk to you all about OpenShift. You might wonder why a person from a competing cloud might be here to talk to you about a cloud solution, and I'm excited to tell you about how OpenShift is a way that we can all work together to get Kubernetes going. So they call OpenShift the Kubernetes platform for big ideas. And one of the big problems that we run into when we're dealing with cloud native development is how to develop quickly. Because we all know that, like, as we're developing solutions for our clients, like, if we're not able to do it quickly, then the value diminishes. And when we're working with tools like Kubernetes, like OpenShift, you're able to work with any kinds of applications that you can dream up. Part of the benefit of OpenShift as well is that, you can deploy it in different spaces. So you can run it on the edge. You can run it in your own data centers and hybrid and multi-cloud environments. Now, if you're worried about switching to a new platform, don't worry, you are not alone. There are a lot of people who are using OpenShift now to deliver value to their clients and pretty successfully, as you can see from some of the companies that are listed here. And part of the things that one of the things that folks run into when they're using Kubernetes is that Kubernetes often is incredibly overwhelming. There's a pretty steep learning curve. And out of the box, Kubernetes needs configuration, different tools that go with it to make it usable for your enterprise environments. And what you have with OpenShift is a set of open source modular components that are built on top of Kubernetes to make it more into a platform as a service, as opposed to what Kubernetes is often referred to as an orchestrator or as containers as a service solution. When you're working with Kubernetes in enterprise environments, you're going to need things like logging and monitoring that aren't really available out of the box with Kubernetes, or things like service discovery. And all of these problems are solved with you when you're working with a tool like OpenShift. Every time there's a Kubernetes release, there's an OpenShift release that goes with it. There's what goes into that release. The biggest contributors to the Kubernetes project are Google, who created the project, and then Red Hat. And they're working on a lot of things inside of the Kubernetes stack to make the tool itself run better, and then present to you a more opinionated view of OpenShift with defect and performance fixes, adding more integrations, and the support. When your Kubernetes cluster falls over, like, who do you call? And when OpenShift, if something ever goes wrong, you have with you the engineering support and the solutions architects, like with Red Hat, to help you solve whatever problems that you ran into. So it's a consistent container application platform that integrates a lot of things that you might look for in Kubernetes that may be difficult to do, or in any of your deployment strategies with cloud native computing. What you have at the bottom is Red Hat Enterprise Linux Core OS, and then Kubernetes on top of that. The way that that it's been put that I like is that Kubernetes is the engine that drives OpenShift. So if you're running OpenShift, you are running Kubernetes, and all of your if you're familiar with Kubernetes, all of your command line commands, your kubectl commands, all of those things are valid in OpenShift. But what you have on top of OpenShift, or what you have on top of Kubernetes, are a suite of modular components that make it a lot easier to use. And I'm going to be able to demonstrate some of that for you today. So yeah, feel empowered to be able to control your application security, defend your infrastructure, and extend your security ecosystem with OpenShift. One of the amazing things that came out of the newer versions of OpenShift is a one-click install, fully automated. So if you are running OpenShift yourself, you're not using it on a cloud provider like Azure or IBM Cloud, you can rest assured that the process for getting it going is straightforward. And updates are pushed to you over the air, so you don't have to bring your cluster down in order to be able to get the most updated security fixes. And why is Red Hat the best choice? Because they're contributing to the code base. They have a lot of customers that are using it successfully. You can use it on whichever cloud you prefer, and it's a comprehensive suite of tools. With that, I want to get into hands-on lab to show you a little bit of what I'm talking about, so it's not just me saying that, oh, hey, this is a great tool. Let's switch tabs over here. I'm going to be using a lab that we've got created for you all. And I said that, OpenShift can run on any cloud, and what you're going to see is a lot of things that are referring to IBM Cloud, but it's okay. Everything that I'm doing for IBM, everything that I'm doing for OpenShift is the same across the different cloud versions. So we have a tool on IBM Cloud called Open Labs, which allows you to get a free OpenShift cluster to be able to build and demo applications. And we have a few tutorials that are set up for you. This one here, when you provision the cluster, you have about 4 hours. This one's only going to take us it's not going to take us the full time. I realize that we're running a little bit behind. But I'm going to show you how to deploy an application on OpenShift, and then show you some of the other features of how it works. So what we have in this exercise one is first talking about some of the things that are specific to IBM Cloud about what you see when you provision a cluster, which isn't necessarily relevant for those of you who are going to be running it on Azure. So I want to just show you what you get when you look at the Openshift Web Console. So when you log in, you get a lot of information that you don't really see in Kubernetes. It's a much more helpful dashboard that gives you access to a lot of information that you'd have to search if you were using Kubernetes. And one of the important things that I like to point out is that you have two personas. You have this admin view and you have this developer view. So depending on who has access and like what people need to do, you're able to direct their access through this through the access control that you've got with your admin and developer views, as well as the multi-tenancy of your cluster. Let's just jump ahead to like what it's like to deploy an application. So I mentioned before that, when you get OpenShift, you have a lot of things that are available to you, like the monitoring, being able to do the multi-tenancy, the security. But for those of you who aren't already using Kubernetes and don't use containers in production, you may be looking for a way that OpenShift might make it easier for you to deploy your applications, which brings me to a tool that is developed by Red Hat called Source to Image. And what that is basically a set of builder containers that are made in a lot of popular languages, and you can add your own languages if you would like. The documentation is pretty good about that, where you can just point OpenShift at a repository of code, and then it will take your code, containerize it, and deploy it to OpenShift and provide you with a link all in one go. And if you're familiar with Kubernetes, you realize that that does take a lot more steps than that. If you're and Kubernetes by itself doesn't have a way to build your container images, and that's something that OpenShift provides. So let's go ahead and get that going. So the first thing we want to do is switch over to our developer perspective. And when you're in the developer perspective, you don't see as much of the information that we saw before. Our topology right here, it shows as empty because there's no workloads found, but we're going to change that. We're going to want to select creating a project. If you're familiar with Kubernetes, there's a concept of namespaces, and projects are namespaces with a few extra features that make them better for the use for use with Kubernetes or with OpenShift. So I'm going to create a project. What do we call it here? Example health. So I'm just going to copy and paste this here. Create that project. We're going to give it that same name, example health. And now we see that we're in the context of example health. OpenShift uses OpenShift to deploy OpenShift. It's all Kubernetes all the way down. So you'll see all of the namespaces that are created that make OpenShift run. And then the ones that we define, you'll see that the default one is there for you, and then whatever ones you create on top of that. The next step that we want to create is we're going to use the builder image as the source image, like I said. So we're going to point our cluster at a Git repo. So from Git, I'm going to grab the URL that we're going to use, and you can check out this GitHub repository of the application and see what it is that we're deploying. It's a simple Node.js application that would be a sort of front end for a health app. It's all generated data. There's no one's actual like medical information in here. Don't worry. And then we're going to navigate to the repository path. We're going to look at the advanced options, and the actual application that we're deploying here is this node source to image OpenShift master. So we're going to drop that in the context directory so it knows exactly where to look in our repository to build our application. And then we're using a Node.js builder image. Node.js builder image, and we want to change the application name to patient UI. This is going to make it easier for us later to know like where this is the front end of the application, and in later labs there's the back end as well that you can deploy, and it shows you how to manipulate those separately. So I'd encourage you to check that out if you do want to look at how this application is built and how to do these examples in your demo OpenShift cluster. And then we're going to hit create at the bottom of the application page. And you see this box checked, create a route to the application, which is what will automatically give you the URL to hit whenever you deploy. So we hit create and we get taken to our topology window. This is what it looks like. And we see that this build is pending, and we can get some more information about it by clicking on it. What we see is that at first it just tried to pull the image, checked if it was in our container registry, which it's not. So it has to build it. So we see that build one is running. Let me jump back, make sure there's nothing else that I'm supposed to point out here. So what you see at the top are the pods. It's trying to create the pods for each of your containers. So the way that, so containers at their core are processes that are running in isolation. And with Kubernetes and with OpenShift, we don't talk in terms of containers necessarily, we talk in terms of pods. So you can think of pods as a group of one or more containers that are running in isolation. And if they're running together in the same pod, then they're going to be some tightly coupled resources. The next thing you see is the build. So we have the build one that's already complete. We have services. If you're familiar with services, it's essentially a way for us to route traffic to our pods. And then we have routes, which is the public URL that we want to hit. And while I was giving that explanation, you could see that our circle here turned blue and the application itself is running. And we can either hit this button here or hit the route itself to see our application running in production. So that was it. It was like we had our Node.js application that was built. I entered some information about it and pointed the URL to it. And while I was explaining the outlay of it, we see that the layout of the topology view, we see that our application has already built and deployed. This is just a sample login. So whatever you enter here will work. So I just put test and sign in. Don't save that. And you can see the information here. This is our application. And it's just like especially if you've never used something like Kubernetes before, or even having not used containers before, like this is just a pretty quick way of being able to take an application that you've already built, get it deployed in a secure cloud native way. So the next thing that I'd like to point out for you is that there is a CLI that's available as well. So it's not all just using the beautiful UI that you have there, that you can totally customize the dashboard. All the tools are there for you to be able to do that, so you can see what information you'd like. But if you're working more with from a shelled into the resource, the CLI is there for you. If you're familiar with Kubernetes, you might have seen the kubectl, kubectl, kubecontrol, however you want to say it, command used. And OC is the OpenShift CLI, and it extends the ability of kubectl to be able to address OpenShift specific things. But you can say, like, if you know the kubectl command, you can use OC and it'll still work. Okay, so in the lab, we simplified the process. So you can log into your cluster by clicking here. These are all of the things that are pertinent to my cluster because it knows like from what it's set up in the background. And you'll see a success message. Get nodes will tell you about the actual hardware that your cluster is running on. So we have 2 nodes here. And we can see the IP addresses of the nodes, see what status they're in, how long they've been spinning, what version they're running, everything that we need to know there. And then if you want to see all of the services, all the deployments, and all the pods that are currently running on your cluster, you can hit this button here to OC get services, deployments, pods, all namespaces. And we talked about namespaces and projects. Again, these are like projects are just namespaces with a few extra features added in. And since our terminals got a little cluttered, we can just clear it out there and OC get projects. And I mentioned before that, you know, OpenShift uses OpenShift to deploy itself. So all of the same resilience that you get from OpenShift's deployments are there for your applications as well, in case something crashes or fails. You know, the same way that the entire cluster doesn't fall over when a small component does, you can design your applications to do the same thing here with OpenShift. And we can see this example health one that we created just a moment ago. If we want to target that project, we just say OC project example health. And it tells us that we're now using that project, so we're in that context. And we can also get the routes that are associated with that project. So this is that URL that I was saying before that I hit to show the actual application that was running. So in the next exercise, we want to look at like logs and events. And so we need to create some work for our cluster to be doing. So we're going to add another terminal here. And we're going to send it an infinite loop that's just going to be querying information so that we can actually see work being done on the cluster. So we're going to simulate a load this way. And while the output is ticking, we know our cluster is getting hit. So the next thing we want to do is have a look at the logs. So out of the box, this is what's available in OpenShift. And you can add in different operators, different software suites to extend that even more if you would like. So in our topology, we're going to look at our pods and then look at our logs, and it's going to show us the load over time. So jump back to our topology, look at our pods, and we're going to see that, look at our logs, and we'll see each time our infinite while loop hits the endpoint, we get a little ticker here in our log that tells us, oh, hey, we got hit for information. The other thing that we want to look at are the events tab, which tells us chronologically what's happened over the course of our application deploying. So you always have like some source of truth of like how this whole thing has been going on. And, you know, we can see that, you know, the pod was successfully assigned, and then it pulled the image, started the container, and then started the container again. We must have changed something or something changed, and so it spun up another container. Oh no, that's the route. Sorry. So we got the application running, and then we got the service and the route running. So the events view is useful for identifying the timeline of events and finding potential error messages when the state of a new rollout, when tracking the state of a new rollout, managing existing assets, or even something simple like exposing a route. The events view is critical in identifying the timeline of activity. So let's look at what metrics and dashboards are available as well. And for this, we have to switch back to our admin view, our admin context. And then we're going to look at our monitoring and our dashboards. And if you're familiar with working with Grafana, we're looking at the wrong, let's look at our compute resources pods and look at the example health one. So this is over time, what happened. Like we initially created the pod here about 5 minutes ago, and then we started hitting the infinite loop about 4 minutes ago, and we see the CPU usage spike because it's answering all of these requests. And our memory usage jumped up, and then pretty much everything is cached, so we don't have to worry about that. But you get as much information as you would like, and all of this is being fed to Grafana by Prometheus. If you're more comfortable looking at a view like that, you can look at the Grafana UI here, log in with your OpenShift credentials, and then you'll see the more traditional Grafana outputs, and you can make your own dashboards if that's something that you like to do, or maybe you have your own that you want to bring in for monitoring Kubernetes. But yeah, we can look at the same thing here, and then look at our example health namespace, and we get the same information. And all of that is out of the box with OpenShift, that you would have to do some configuration and monitoring and management to be able to do with Kubernetes. So everything is just kind of there for you. Also shipping with it is Alert Manager, so you can use Prometheus to set up alerts, set up queries, custom alerts for anything that you'd like to do. But the really interesting thing that I like with OpenShift is how intuitive it is for us to scale our applications depending on load. So we can imagine that we're looking for elasticity with Kubernetes. If we have a lot of traffic come in, we want to be able to scale our application up. And when that traffic dies down, we want to be able to scale it down. So we're looking at that ability to do that. And our horizontal scaler that we have in OpenShift makes that really straightforward. Now we're going to dig into a little bit of YAML, but it's okay. We have everything here for you that you can copy and paste. So there's less of a concern of messing things up. So from the admin perspective, we want to go look at our deployments, which manages our application, like manages the pods that are out in the world. And we're going to look at our patient UI deployment, and then we're going to edit that deployment. So let's go do that. So if we go, oh, no, it was under workloads there. I closed it. Workloads, deployments. We're going to look at our deployment here, and we're going to take the action to edit our deployment. And then we get to this YAML tab. It's color coded. There's a little bit of linting there for you if you make a mistake. So yeah, don't worry. We'll look down as well in the YAML editor at line 46. We'll see the resources, and we want to set some resource limits per pod. So let's just copy this here so that we don't mess up the indentation. So line 46, we're going to replace that with that block of text. We're going to save it. An error. So I made a mistake with my YAML. What did I do? Oh, this line came out and it wasn't supposed to. So that's my bad. That should be at that level. Save it. Okay, good. Reload. So if you make a mistake, it catches it there, tells you something's wrong. Just take a close look at it, make sure you didn't make the same mistake that I did, and then you should be all good. So we saved and reloaded that to see the new version. And we can look at our events to verify that our replication controller has been changed. And our replication controller is what's responsible for us spinning up new copies or spinning up just copies of our pods. And if we look at our events, we'll be able to see that that's been updated. So let's go to our events and see, created a container deployment. So it scaled down our replica set. It deleted the pod that was running, stopped that container, and it's gonna, before it did that though, it spun up all the new ones. So let's go a little bit further back in time. Let's see. Yeah, so we've got a new replica set coming up, deleting the pod, scaling up to 1. So that's creating that new one a minute ago. So we took the new deployment and made a new pod that follows those rules. Once that pod was healthy and up and running, then we started scaling down the other one. So once we successfully pulled the image and started the container, then we scaled down the old one. So that's like that process of like the application never going down as we're updating it. And then what we're going to see is that when we have the resource limits in place, we can set up an autoscaler. So we're going to look at our workloads deployments and look at what the deployment says, how many pods there are. We're going to set up our horizontal pod autoscaler. Let's get to that point and then we'll come back here. So we want to look at our deployments. And then we're going to look at our horizontal pod auto. So like in the deployment, if I click this up button here, it will give me a second pod. But we don't want to just be sitting here watching that. It's like, oh, the application seems like it's overloaded. Let's add a bunch more pods. So for now, I'm just going to leave it at 1, and we're going to have everything set up to do that for us. So when we create a new horizontal pod autoscaler, we're going to need some more YAML, but don't worry, we've already got the YAML created for you. We're going to copy this whole block and just replace everything. Take note of the values we're setting for the minimum replicas, the maximum replicas, and the target average utilization for CPU. The value is artificially low, but it'll allow us to see some scaling go into effect, provided our traffic script is still running. So we're not seeing a lot of traffic, so we want to set that bar a little bit low so they're actually seeing what we're intending to see. So I'm going to jump back over to here, paste in our new YAML, create that horizontal pod autoscaler, and we're going to watch it work. So yeah, it'll take a little while automatically, but if we look at our if we go back to our deployments page, we'll see that there's 1 pod running now, and we'll just let this tick over for a little bit until more pods are created to handle the workload that we've already got going from that infinite loop. That just make sure that's still running. Yep, that's still running, still hitting that. So yeah, after a little while, we'll see that we'll see that go up. While we're waiting for this to take place, do we have any questions that folks have about this whole thing, about how it's going? Or any questions about OpenShift or Kubernetes in general that I might be able to answer?
Die zijn er.
You don't? Okay.
Oh.
Well, of course, this is a mini Azure community. If you're looking at this section too.
I'm sorry, I can't hear what you're saying. So what's that?
Is your mic on, right? Nigel, I think we're having some sound issues here.
Okay.
But there are no specific questions at this time.
Okay.
I'm just checking the sound, yeah.
All right. No worries. Okay. I just flipped back over to the page, and you can see now that 4 pods are running. If you caught it, it said 1, and it was creating 4 or creating 2 more, and it automatically scaled
Complete
up to 4.
blanco. Anyway.
And now it's seeing there's even more load that the 4 pods can't handle. So now it's scaling up to 8. And we set a max of 10, so it won't scale up past 10. But if we look back at our dashboard, we can see more pods coming up in our namespace to handle the load, to handle the limits that we set. So more and more pods are spinning up that are replicating the same application to spread out the load, and Kubernetes is handling the load balancing between the pods to be able to give, does it round robin, but to make sure that and that's configurable, but making sure that each pod is handling a good amount of traffic for what it can do. And we're all the way up to the max 10 pods. So essentially what we wanted to cover was to give you an introduction of being able to run Kubernetes with OpenShift. So Kubernetes being this big monster that can do so many things, but a lot of times it can be overwhelming. And sometimes we're looking for a more platform solution to be able to handle our application deployments. And that's where OpenShift can come in for you if that's what you're looking for. We took an application, we deployed it using source to image, so we didn't actually have to create our containers. But if you already have container images that you want to bring in, there's generally no problem with that. There's a few caveats there. But you can run your container images that you already have. You can even import all of the YAML. You saw me editing YAML there. You can set up all your deployments and apply your YAML like you might be used to with Kubernetes if you want to try out OpenShift. But I'd encourage you, if you find a playground, we have them here at the Open Labs on developer.ibm.com. And then we have OpenShift Red Hat provides them through learn.openshift.com to be able to check out OpenShift and see for yourself if this is a solution that would work for you. And you can run it on whatever cloud provider you like, or run it on your own infrastructure.
Okay, thank you so much. You saw some very powerful stuff there. Thank you for that. And as this was of course for an Azure community. As an Azure community, what would you say is the unique selling point choosing OpenShift over AKS?
It's going to be a lot of the same things. I mean, AKS is going to have a lot of tools in there to make it easier and probably be able to play nicer with all of the sources that you have deployed on Azure. But it's going to be the experience that you're looking for with a managed Kubernetes versus a platform for using Kubernetes. Even with AKS, there's a lot of tooling that's in OpenShift that's not available in AKS. So I would say just do a feature comparison of what you see on AKS versus a more platform solution like OpenShift. Does that answer that question?
Yes. Yeah, I'm really we'll be looking into that feature comparison then to just have the differences. Thank you.
Yeah. And also, just having support. And then there's a lot of things about, what does it mean for something to be secure by default? And I don't necessarily believe in that phrase because there's going to be security issues everywhere. But when you're looking at the operating, so from the bottom of OpenShift, you've got CoreOS, which is an operating system that is built to run containerized workloads. It's not a OS that we're using to do it. It's something that was purpose built for that. And we often know that purpose built things typically tend to perform better than things that we're using for a particular purpose. And then all the way up to Kubernetes, and then these modular components that are added onto it to make it the experience that we saw, where it was just if I wasn't talking, I would have had the app deployed in a minute tops, and going from having source code to application in the world, here's a route, use this URL in a minute. I think that's pretty cool.
It's very cool. Thank you so much.
Yeah, no worries.
Yes, awesome. So we're moving on to the last speaker of the